Everly, and welcome to Module 2, the Basic Formal Ontology Practitioner Series. We're working on a certificate now for Basic Formal Ontology, and it's as one of the foundation certificates for the National Center of Ontological Research Academy. And so, as I said, you'll see here John Beverly. I'm the co-director for NCORE, assistant professor at the University of Buffalo, and affiliate faculty for Institute of AI and Data Science here at the University of Buffalo. I will be your guide as we explore today some of the methodological convictions in Module 2, underwriting the basic formal ontology. As if you recall, hopefully you joined us, that is, for the first module, where we explain some of the motivations for basic formal ontology. As we proceed through these modules, we'll get deeper and deeper into understanding basic formal ontology and how it's used in the real world and how it can be developed in the future. So today, again, as I mentioned, we'll be discussing the methodological convictions of basic formal ontology. It's kind of like a high-level bird's eye view before we get into more details when we discuss the theory, and then into the weeds and the logic in the last module. So just a reminder, basic formal ontology is a top-level architecture. It's used by over 700 open source projects and quite a few in the closed source as well. It leverages basic principles of logic to make explicit the implicit meanings buried within data. And there's a picture of basic formal ontology. It's very few classes, some structure that relates things to other things. We will be discussing in minute detail all the parts of that structure, as a matter of fact, in the third module. But today, as we will be discussing some of the background before we even get to that structure. What is it about basic formal ontology beyond that hierarchy I was just showing that makes it so appealing, that makes it so useful in addressing information silo problems and challenges? What made it so attractive to the open biological and biomedical foundry community, or ontology foundries community, as well as the industrial ontology foundry community and the DoD-IC working group? So, well, some of that has to do with realism, which you see right here, which is basic formal ontology is designed to represent the world proper, rather than just concepts about them. Now, early in the days of ontology development, it seemed to be the norm that ontologists tended to focus on modeling the way individual researchers or groups conceptualized how the world was. And this has its origins, I think, in Tom Gruber, some of his early work in the start of ontology engineering, where he had introduced one of the first definitions for ontology, and he called that a specialization of a conceptualization, and went on to talk about the world. Now, that specialization, basically like a really precise formal characterization of, and he was saying, a conceptualization, like your concepts or your way of understanding the world. Basic formal ontology does not take that line. Instead of modeling concepts, it models the world first. Now, it is not the only top-level ontology. There are other ontologies that were born out of Gruber's observations that do focus largely on concepts, almost entirely from the conceptual point of view. We in our circles, I don't want to throw stones here, but to me that gets things quite backwards, if anything, just because if you start with modeling concepts, then you can't get to the world. There's no path from getting to concepts into the world, but if you start with the world, then you can model concepts. And so, to my understanding, my interpretation of realism, especially as it's in contrast to conceptualization or modeling concepts, is that we have a bigger boat, we have more flexibility, we have a broader structure. When I can model your concepts, I can model the way that users speak about a data set, I can model the way that people think about a data set, and I can also model the data set, right? And I find when I'm working with stakeholders or sponsors that this is an important point to keep in mind, because ontologies, as we use them, are specifications of the world, and if we attempt to go from the words we use and then model the world, it's unlikely that we will end up in the same place. But if we attempt to go from the world to the words, it's much more likely we will remain coordinated. And you can see this in practice, just a little bit of an active learning exercise right here. So if I asked you, audience, as you're listening, to go write down your best definition for tank, I ask 5 people, I'm going to get at least 4 different natural language conceptualizations of what a tank is. And they're going to have some commonalities, but they're also not. They're also going to come apart. Now, we could start there. We could start with these different conceptualizations and try to figure out what's in common across them. We could try that. I assure you, and every time I've ever tried to do this with a group of people, we got bogged down in arguing about words. I don't want to argue about words. I want to argue about the world. And by the world, what do I mean? I just mean that basic logical structure. Hope you recall from the previous module, I said we aim, when we're doing ontology engineering, at modeling the basic formal structure of the world that's common across all data sets or common across all ways you might talk about data sets, so that I can give you a foundation. We can give you a foundation, logically firm foundation, on which all of those ways you want to talk can be built, on the top of which all of those ways you want to talk can be built. That's what I mean by the world. The logic doesn't change. The logic is just there. We build that. That's what we aim for. The world, not your concepts about them. Logic outstrips the concept. So again, I'll emphasize, when we're talking about realism, I'm not talking about some metaphysical sense of like, how do we know, or what's out there, what's the truth maker for our various claims, or some epistemic sense. It's like, how could we know, or what sorts of access or connection do we have to the world? I don't mean any like philosophically loaded characterization of realism like that. What I mean is a very practical interpretation of realism, which is, if we start arguing about words, we're never going to get past the words. If we insist on focusing on the world, we can get to the words when we need to. And so basic formal ontology adopts that realist stance. This is very useful because if we're focusing on the logic, what we can do is disambiguate the words. We can distinguish things like information from what information is about, like a set of occupation codes versus the holder of an occupation, like the way the international standards like the US SOC characterizes a pharmacist. Just that coding is not the same as the pharmacist. We disambiguate information from what it's about. This is a very common confusion. People regularly confuse information from what that information is about. We also distinguish material things from immaterial things, such as a river, like the water, the material that composes a river, versus the site where the river used to flow. Like there is a place somewhere on a map, historically speaking, where a river used to flow. Like the rivers change their courses all the time. It takes hundreds of years, thousands even, for that. If you're tracking or looking for the site of where a river once was, you're not exactly looking for that river anymore. The river could be there. The Mississippi could still be over there, right? Like in a different place. You just want to see that site where it was. One of those is a material thing. One of those you can get into and get wet with. The other one you can move through, I suppose, but it doesn't seem to have material parts. Now, you can also distinguish in the sort of basic logical structure of the world things that bear properties versus the bearers of the properties, like the redness of an apple versus the apple itself, as well as processes versus things that participate in them, like the unloading of a truck versus the truck itself. And again, basic observations about logic that are common, universal across different ways of encoding information or encoding databases. Here we have them on display because we're focusing on realist principles of the world. In addition, some other methodological convictions that we adopt include hub and spoke methodology. Basic formal ontology is a hub from which we say spoke ontologies extend. An analogy here might be helpful, especially to those of you with more of a programming background. So basic formal ontology you can think of as analogous to the Python programming language, where extensions of basic formal ontology are analogous to libraries. You could, as I'm sure you know, create code that allows you to interact with data frames, or you could just start with Python and import pandas. Now, on the other hand, similarly, you could create ontology elements that allow you to model artifacts and processes, or you could instead just start with basic formal ontology and import extensions that refine some of its content as a hub would to its spokes. Now, and there are many ontologies that do just that. As I've said, basic formal ontology is a top-level, high-level architecture. It sits on top of more specific ontologies. So not every domain is really high level, just talking about bearers and properties, and like not very few like databases talk about this high level stuff. Most databases, most information systems want to talk about more specific content, things closer to the ground, like things in industrial ontology or industrial manufacturing circles, as you see here in that IOF core, which imports basic formal ontology. That's an ontology that covers industrial manufacturing. It has spin-off ontologies that represent skills and assets and observations. In general, you see here, there's the BFO Sun, and then there are as a hub, and then there are spokes that spin off of it, and ontologies are extended from basic formal ontology through downward populations, where new classes have parent classes, new terms have parent terms, ultimately leading back to basic formal ontology. Now, just illustrating some of these, as you see, here's basic formal ontology again. Here, the class structure. It's a rather simple hierarchy, and it's extended in various ways by these other ontological structures. Again, this is the Industrial Ontology Foundry core, which imports basic formal ontology. And you see, if you just observe here, and you see entity at the very top of basic formal ontology, then you have continuant and occurrent and an immaterial, material entity. And don't worry, we're going to go through these in quite a bit of depth in the next module. But if you'll just observe here, that you will also see in this image, while this arrow is pointing directly to that IOF core, you'll see BFO built into it. So entity at the top, and then continuant, right? And under that, you have the more industrial terminology that you might come to expect, like products or manufactured products or resources. You also see on the right-hand side of this image, occurrent, which is another basic formal ontology class. It's a sort of place where you put things that happen over time, and in that you have processes, agentive processes or planned processes, business processes. So as you can see, BFO sits at the very top of these architectures, and then more specific ontologies introduce their content as they extend down from basic formal ontology, like a hub and spoke structure. Another very important example of this, as you see, this is just the import, we say the import structure, representing the common core ontologies and its relationship to the basic formal ontology. Common core ontologies being a suite of ontologies that extend down from basic formal ontology, are widely used in defense and intelligence sectors, and they cover the suite of ontology cover things like events and agents and qualities and artifacts and geospace and time and information. These are, as you see here, this common core ontologies in the dark blue. These ontologies extend down ultimately from basic formal ontology, and they have more specific content than what you would find in that rather high level quality, relational quality, temporal instant, temporal interval kind of structure that sits at the top. You're not going to get an event or an agent in basic formal ontology, but you will get it in its extensions like the event ontology or the agent ontology. In addition, basic formal ontology adopts fallibilism, which is its commitment to tracking scientific research over time, which may change and often does. We want to recognize the fact that things do change, much like science used to recognize the existence, or at least postulate the existence, of something called phlogiston, which was I believe some sort of fluid that carried heat, I believe. My history of science is failing me, but it was postulated as a phenomena that existed, something that could be tested, and there were many attempts to identify or whether or not it existed. Of course, they ultimately concluded, researchers did, that it did not exist. And so science is sometimes wrong. Investigations sometimes turn up on dead ends. What we want to do, because we're trying to reflect the best science of our day, the best research of our day, we're tracking that. We take that as our touchstone when we're building this, like the basic fundamental logic of the world. We recognize that we have to change sometimes too. Not everything we build is going to be the end of our building. Like we have an ongoing, continuing development process. We change as needed when science changes so that we can remain in lockstep with it. An example of this and another extension of the basic formal ontology can be seen in the occupation ontology, which is an ontology that is essentially designed to represent occupation coding standards from international groups, and it is also quite high level. As you see here in yellow, you have like the basic formal ontology content like process and occurrent and continuant, and then in green you have some of the occupation or OCCO classes here, like occupation activity or an occupation role or a skill or ability. It does sit in, it sits in the orbits here, extending down from basic formal ontology. But it's worth noting that although this ontology, the occupation ontology, is designed to represent occupation codes, those often change. Sometimes jobs that used to exist stop existing, like a leech collector who was apparently responsible for retrieving blood-sucking worms from their natural habitat. And while such a job does not exist now, it did in the past. And so while we might have at some point needed to have an occupation code for such a job, we certainly wouldn't now. And if we had constructed ontologies that represented leech collectors, we would need to take heed that such things might not exist over at some point. And similarly, we don't even have to come up with hypotheticals. If you go scour the news here, it won't take you long to find that there are concerns about AI taking over jobs all over the place, especially now with large language models and the impressive feats they're able to accomplish. You'll see headlines such as 10 disappearing jobs that won't exist in 10 years. And you also see 7 jobs that don't exist today but will in the next 5 years because of AI. So again, we're taking heed, we're taking lessons learned from existing research, and we recognize the basic formal ontology and the ontologies that extend down from it to adopt this fallibilist stance, in the sense that we are not perfect, we don't purport to be. What we do is track the best bet research, the best going research, that is, of the day. Now, lastly here, I want to highlight this methodological conviction of basic formal ontology, namely adequatism, which is that basic formal ontology is not reductive. The classes and relations that are motivated by research communities are not just paraphrased away. We're not trying to take terms and reduce them to other terms. We're not interested in, say, some minimal or sparse ontology where all of the qualities in the world can be reduced down to their bearers, or vice versa. All of the apples in the world can be reduced down to their qualities. We're not trying to do that sort of paraphrasing away. We're not trying to get rid of processes in terms of just the things that participate in them, or vice versa, to describe just the processes themselves, and indirectly in doing so talk about things that, like you and me, and tables and chairs that participate in them. We want all of it. We want the kitchen sink, because that's how research is conducted, and we don't find a need. In fact, we find it detrimental to try to paraphrase away what research communities find it useful to talk about. We want to characterize their logic, and that characterizing what they believe exists in the world. I'll highlight here again the occupation ontology and its kind of overarching goals, which was to illustrate this point. So the occupation ontology sits atop various occupation coding standards like USSOC and its ONET database that's uncovered, or at least informed, by a national compensation survey from the US. Also the European Classification of Skills, Competencies, Qualifications, and Occupations, or ESCO, which is generated in the international community from subject matter expert investigations. Now these sit in, like, the occupation ontology is supposed to sit on top of these and identify semantically where they overlap, and it does identify where they overlap and when they don't, with rich logics that connect these things. But it's also informed by other research, other areas discuss, or other knowledge bases that discuss occupations, things that USSOC, for instance, or ESCO is not drawing from. So where U.S. Bureau of Labor and Statistics is informing USSOC, so is the National Compensation Survey. There's a whole mess of research out there about occupations on Wikipedia, which informs the knowledge base Wikidata and the knowledge base DBpedia, which is also the sort of under the layer, under that semantic layer of the occupation ontology, which is important because while ESCO, USSOC, they don't cover everything within their intended scope, a common semantic layer connecting ESCO, USSOC, and other standards allows for cross-validation, identification of gaps in coverage, overlaps in synonyms and descriptions. It really helps you enrich the structure. And again, I say this as part of the adequatism because we are not trying to paraphrase away the data that you see in Wikipedia or the data you see in Wikidata, or we're not trying to explain everything in USSOC in terms of ESCO or everything you see in ESCO in terms of USSOC. I don't think anybody will be benefited, for example, by trying to explain the way ESCO talks about occupations in terms of the USSOC way of talking about occupations. What we instead should do, and what we're doing here, is attempting to identify where they overlap and then observing gaps and then cross-validating and then looking for similarities and differences across them within and using external data. So you can see here just some examples. ESCO takes subject matter expertise to inform its labels and its descriptions. USSOC takes these various surveys. They have overlapping definitions, overlapping scopes. But then they are supplemented here. There's missing information between the two that can be pulled in from these other databases. And again, not trying to paraphrase it away, just wanting to bring it all together to see what we can learn from these various data sets. And this is right in hand. Again, I want to emphasize, it's worth emphasizing 1,000 times, if not 1,000 more, that what we do as ontology engineers using basic formal ontologies, we make explicit, implicit data using basic principles of logic that connects data sets from one group to another, covering the same or different domains. And that is what I'm illustrating here in these four methodological convictions that I've described: realism, the hub and spokes methodology, the fallibilism, and the adequatism. They are some of the cornerstones on which we engage in this practice and have done so successfully for decades and will, as I do hope, I do believe, for decades to come. So with that, I will turn your attention here to Module 2 check. If you don't mind, please navigate to the module here using this link. Some questions to check your comprehension. Some of them will be quite challenging. I trust you. But if you have any questions, go through the module again and try once more. So with that, I will close in looking ahead. In the next module, we'll get into the real theoretical weeds of basic formal ontology, and by end you'll have quite a firm understanding of that rather small hierarchy but rather rich logic underwriting it.